how to populate those, and how to run few queries like select, statement, where clause, and what are the different operators which you can use with where clause, how to sort the data, and all of those which I've already covered in the previous sessions. From today's sessions onwards, we'll be going into functions and understanding how we use functions in MySQL, right? And we'll also understand how you can use those functions together with group by. So all these are functions. So count, sum, min, max, average. All of these are very useful functions in MySQL, which allow you to aggregate data very easily. So that's our goal for today's session, to understand what these functions are and how to properly use them. Then we will understand what is group by and how to perform group by operations along with these functions, and various ways in which group by is useful. Then we'll take a look at how to filter data after a group by has been applied, and what is the difference between a having statement and a where statement. Next, we will take a look at some useful date functions. And finally, we will take a look at case when statements as well. So that's the roadmap for today. And this is what we'll be covering in today's session. As always, we'll cover some theory first, and then we'll jump into the hands-on sessions. So what exactly is aggregations? So aggregation simply means that whatever numerical data you have available, you take those numerical data and convert it into a point estimate. For example, you could use a point estimate like sum. That is, I give you a column which contains salaries of all the employees in my company. And I could ask you, okay, tell me how much do I pay to all the employees on a monthly basis? So that you can calculate by adding or summing across all the salaries that you have available. You could also ask, okay, what is the average salary for this department which you are interested in? For that, there's a function available called average, which will aggregate those rows and convert it into an average point estimate for those rows. Similarly, you have max and min as well, which are useful when you want to calculate the maximum salary which you are paying or the minimum value across those numerical columns. Also, we'll take a look at count function. Count is used to count the number of entries that you have available. So if you're interested in finding out how many rows you are getting after you have run a select operation or any query which you have run, you can use count to see how many rows are getting filtered after that operation. So count is used to count the number of items that are basically getting returned by a query. So that's essentially the aggregation. So aggregation is nothing but it allows you to convert a set of values into a single point estimate. And then you can use that point estimate to summarize your findings. Hope that's clear. Now, in the previous sessions, I have mentioned this, that whenever in MySQL data is missing from a particular cell, it is represented with null values. So in any MySQL table, if you find null written over there, null indicates that the values are missing in those cells, right? So null is a data type that specifies where data does not exist in SQL. So wherever in a particular cell, from cell I mean a particular location in a column. So if in a column a particular entry is missing, then that is represented as null in MySQL. And you can also use nulls and aggregations together, because what happens is that, for example, you want to know or you want to understand how you can count the total number of null values in a particular column. So how you can do that? You can essentially use the count function for it. So count actually counts only non-null values in a particular column. So whenever you want to count all the non-null values in a particular column, you use the count function. So here you already would know total how many rows are present in a column, right? So you already would know how many rows are available in a particular table. And then if you use count function to count number of rows in a particular column which are not null, the difference between those two would tell you, okay, how many null values are present in that particular column. I'm repeating again. If you calculate the difference between total number of rows in a table and the number which you are getting returned by the count function, and I'm saying this again, that count returns the total number of non-null values in a particular column. Right? There are multiple ways of using count which I'll demonstrate in the hands-on session. It essentially returns how many non-null values are present in a column. So let's say in a table I have 20 rows. So in a simple example, I have a table which contains 20 rows. In that table, there is a column in which 5 values are missing. So if I use count for counting the number of entries in that column, the result which I will get is 50, because 5 out of those 20 rows in that column are missing. So difference between 20 and 15 is 5, which will tell me total number of missing values in that column. So count can be used to count how many values are missing in a column even, right? Because it does not include null values when counting a particular row. Hope that's clear to everyone. Right? So as I mentioned, count does not consider rows that have null values. Therefore, you can use this to quickly identify which rows have missing data. We understand this as well. So now let me open up my MySQL workbench, and then we'll practice these one by one as well. Just give me a second. So I'm again in my MySQL workbench. We have been practicing using this file as well. So I hope everybody here is on the same page. Now the agenda for the day is to understand how to use various functions which we have seen right now. Right. So first we'll be starting off with the count function. As I mentioned, count function is used to count the number of rows in a particular table. So here, starting off, I'll use a simple expression. So I'll use select count star from employee table. So before running this query, what I'll do is that I'll execute a statement called use company DB, because the following statements I want to execute on my company DB database. So therefore, I'll first execute the first query which I have written, which will allow me to run all the further queries on my company DB database. And this employee table is available in my company DB database as well. So that's why it will allow me to run this query over here. Now what I'm doing here, I simply executed this simple command. Now if I execute this command, the output of this command will tell me total how many rows are there in my table, right? So if I show you all the entries from my employee table, the output of this, you can count the number of rows which we have. So 1, 2, 3, 4, 5, 6, 7, and 8. So these are all the 8 rows which are part of this table. And if you run the count query as well, the output here shall be 8 only, because these are the number of non-null rows in my employee table. All right, so this is the first way of using count. Now let me just print the contents of employee table again. So in this employee table here, what you will observe is that under the supervisor ID column, there is one null value which is present. Right. So if you take a look at entries in the supervisor ID column, there is one null value which is written here. Right. So if I now count the number of non-null values in the supervisor ID column, so here I'll run another query, select count of supervisor SSN from employee table. If I run this, here you can see the output of this query is 7. Right. So the output of this query is 7. So why is this 7? Because this 7 corresponds to total non-null values in the supervisor ID column. Right. So here if I simply calculate the difference of count star minus count of supervisor ID, and I'll rename it as, let's call it count of null under supervisor ID column. So I will create a new column called count null supervisor ID, and this is basically the difference between my total number of rows in the table and the total number of null values in this particular column. Right. So here if I execute this query now, the output here will be 1. So this 1 corresponds to total number of null values in my supervisor ID column. So this is my count of null values in the supervisor ID column only. Right. So what's the difference between these two queries here? In the first query, I'm counting out total number of non-null rows which are a part of all the columns that I've selected from the employee table. So remember, asterisk indicates that all the columns are part of this query. Right. So all the columns are part of this query. But here, what we are doing here, we are first counting total number of rows which are there in my employee table and subtracting from it the total number of non-null values in my supervisor ID column. And the difference between these two entries is 1, which is telling me how many null values are there in my supervisor ID column. Right. And I can even print that row here. So earlier on in the previous session, we have already seen this query wherein select star from employee table where supervisor SSN is null. So we have already seen this, that if you want to filter out rows which contain null values, you can use this query wherein you can filter out those rows with using this condition of is null. So if I execute this query, now it will show me the row which contain null value in the supervisor ID column. All right. So here in this particular case, sorry. So in this particular case, this is the row which contains null values for the supervisor ID. All right. So these are a couple of ways in which you can count how many non-null values are part of a particular column using the count function. Next, we have the sum function. It's a very simple function which allows us to add values in a given numerical column. So if a column contains numerical values or values which represents quantity, you can aggregate those and calculate some of those quantities with the help of sum function. So sum allows you to count the aggregation of adding all the numerical values in a column. The usage of sum function is pretty straightforward. The way you use it is essentially here you can see the syntax. So select sum. Sum is the function name, and within round brackets. So here you have to, after writing the function name, you have to use circular brackets or round brackets. Between those round brackets, you have to write the column name that you have to aggregate. So here you have to give the expression for aggregation, and then from the table wherein you have to aggregate and any conditions that you have to apply. All right, so that's the syntax that we use. Let me go to the present MySQL workbench, and we'll see how you can run these in MySQL workbench as well. So now we will understand how you can run sum function. So in our employee table, we have a column of salary. So what I'll do, I'll calculate sum of salary from my employee table. Right. So once I execute this query, the output of this query will tell me total how much salary I'm paying to all the employees in my company. Right. So for this particular entry here, you can see the total salary is 2,81,000. It's not always necessary to calculate sum for all the rows. If you want, you can also append it with some condition. So let's say you want to calculate sum of salary, but only for female employees from employee table where sex here is female. So what this will do, this query will filter the rows from your employee table for female employees, because here the condition which you have specified is for female employees. So here we'll filter out the rows for female employees, and only for those rows we'll be calculating sum of salary from the employee table. So if I now execute this query, you can see here the sum is different because the rows are lesser when compared to all the rows. So here instead of calculating sum of salary for all the employees, we are only calculating sum of salary for our female employees. All right. So that's how you can use sum to calculate sum of all the numerical values in a column. And here also, when calculating sum, if there is any null value present in that column, right now in our example, there is no null value present in the salary column, but for a second, assume that there are a couple of null values present here as well. If that's the case, in that case, that value will not be considered to calculate the sum, obviously, right? So it will not consider those null values to calculate the sum. Similar to sum, you have minimum and maximum as well, which allow you to calculate minimum and maximum values from a particular column. The syntax of this is exactly the same. The only difference comes in the function name. So for some function, we used sum as the function name. Here, min is the function name for minimum, and max is the function name for maximum. I quickly demonstrate these two as well using our same example from MySQL workbench. So here I'll run a select query wherein I'll calculate minimum salary as min underscore salary. And let's also calculate the maximum in the same query as well. So I'll also calculate maximum of salary as my max salary from my employee table. Let's say where this time let's calculate it for the male employees. So here I have written a simple query in which I'm calculating my minimum salary and the maximum salary. And this I'm doing for my male employees. So this analysis I'm doing only for the male employees. So that's why I'm first filtering out the rows for my male employees. And from those rows, I'm calculating my minimum salary and my maximum salary. And I'm renaming those columns as min salary and max salary. In our previous session, I've already explained the use of as an alias operator. So as is used whenever you want to give an expression and alias. Obviously, if you don't give this, then the output will contain a column which contains the name. Here you can see in the previous query, the output column had the name sum of salary, which is always not good to look at. Rather, we want a column name which is much more descriptive of what we are trying to do. So here you can see I have given an explicit name minimum of salary. So now if I execute this query over here, the output will contain two columns. The first column will contain this column name of min salary. So here you can see the first column of min salary. And the second column here is of max salary. You can see the output column name as max salary. And you can see the output values here as well. So these are the two output values. And these are corresponding to only our male employees. Hope this one's clear. The next function which is often very useful when it comes to doing analysis is average. Average is also known as mean, so you must have heard or learned about it in your elementary classes. So it's often useful when you have been given a lot of data points and you want to calculate a point estimate which is representative of the population. Right. So for example, I give you marks of students in your entire classroom. Individual student marks I give you in a list. Now, obviously, when you report the performance of the entire class, you don't just report the performance of the highest scoring student, right? So whenever a teacher comes and essentially tries to present how has their class performed, the teacher will not say the highest marks scored by my class student is this and this. What they often try to look at is what is the average performance of the class. That is, if you calculate average across all the marks of the students, that number that you get is more representative of the population that you have, right? Because the highest marks are scored by just one student. So that statistic is actually making use of only one data point, which is the highest marks of the student, right? So let's say out of 50 students, the highest marks that have been achieved by students are, let's say, is 99%. So if the teacher reports the highest percentage, she will always say, yes, the highest marks that have been scored by my class student is 99%. But that only considers the one student marks who has scored that 99%. The remaining 49 students have not been incorporated in that analysis. So a much better estimate of that performance comes by reporting it as an average. So what you do, you calculate the average across all the marks of 50 students, and that value which you will get will be much more representative of your population's performance. Here population means those 50 students in that classroom. The way average is calculated is very easy. So it's a ratio wherein in the numerator you have sum of all the values and in the denominator you have total number of values. So in this case, in the numerator you have sum of all the marks of the students. So all those 50 students that you have, you calculate sum of those 50 students, and in the denominator you calculate the number of students in your class. So let me show you both the ways in which you can calculate average manually as well as using a function in MySQL. So first I'll simply show you how you can calculate average manually. So let's calculate the average salary for our employees. So in the numerator we have the sum of all the salaries, and in the denominator we have count of number of data points in my salary column, and I'll rename it as my average salary from my employee table. So here, as I mentioned, this ratio here will tell me the average salary for my employees which are working in my company. So it's a ratio in which in the numerator you have the total salary, and in the denominator you have number of data points or the number of count of salary column. And this ratio will tell you about the average salary of your employees. So if I execute this query here, you can see this is what the average salary of my employees is. If you don't want to calculate it manually like this, so there is an average function which is available as well. So you can see this average function is also giving you the same result. So this average function also returns you this ratio in which in the numerator it calculates the sum and in the denominator it calculates the count of that column. All right, so this is what the average salary for your employee table is. And this estimate, you can use this estimate to report, okay, this is what an average employee earns in the company, right? So, but what you will see is that this average salary is more representative of the population that you have, because obviously the maximum salary that anybody is going to earn in this company. So if you calculate the maximum salary, both of these values will be extremely different. So here you can see the maximum value is 55,000, whereas the average value is 35,000. So there's a huge gap between these two. So whenever reporting a point estimate, people usually prefer using average over maximum or minimum values, because average incorporates all the data points when calculating that point estimate, whereas maximum or minimum usually incorporate only one data point for reporting those numbers. So they are not representative of the population that we are working with. Now, until now, what we have seen is use of these aggregation functions to aggregate all the rows that we are filtering or not filtering. Right. So right now, what we are doing is that if you want to calculate the sum of rows, we don't have an option to aggregate data based upon a category. Right now, all the aggregations that we are doing, those aggregations are getting calculated on the global level without having any option to separate those aggregations for, let's say, a category wise separation. For example, I want to compare the average salary of male and female employees. So if I want to do that, right now, what will I have to do? I will have to run two separate queries In the first query, I will have to filter rows from the male employees, and in the second query, I will have to filter rows for the female employees, and then compare those two numbers to get a comparison between those two salaries. So this is a very time consuming process simply because multiple queries have to be run. What if your category contains 10 separate values, right? So what if you want to perform, you want to make a comparison between average salaries of all the departments in your company. Now in a company, you can have 5, 8, 10, n number of departments, and calculating average salary of each department manually by writing each query again and again and again will be a very time consuming process, and keeping track of all the numbers is also a very tedious task. So in order to make such operations much easier, wherein you want to perform aggregations, but those aggregations have to be performed on a category level. That is, for each category, the aggregations have to be separated out for each value in that category. That's where group by comes into picture, right? So here, what group by does is that it takes your entire data. So I'll explain this with an example. For example, let's go back to our employee table. In our employee table, we want to analyze the salaries of male and female employees. So for that, what it will do, if you apply a group by based on the gender column, so what it will do is it will create two separate tables, or two separate, you can think of it like it will separate the entire table into two groups. First group will only contain records from the male employees. Second group will only contain records for the female employees. And it will separately calculate the aggregation for each table. So for the male table, it will report the aggregation for the male salary, and from the female table, it will report the aggregation from the female salary. And it will join those two together and create an output which will contain both the numbers in a single table. So the analysis will become much easier for you. The way you perform group by, the syntax of this is written on your screen right now. I'll explain that with a practical example so that it becomes much easier to understand. So the way it is done is that select, then you write the column names that you want to select. Then how do you want to aggregate? So here the aggregate function has to be used. So remember that group by is always used along with an aggregation. So you have to write an aggregation column, aggregation function. So in this case, the aggregation function could be sum, average, minimum, maximum, right? So any aggregation function can be used here. So you write the aggregation function name and which column you want to aggregate using that function. Then select the table from which those columns have to be filtered. Then any condition that you want to write and the final group by expression that you want to write. So after group by, you will have to write the column that you want to group this expression by. If it is not clear, it will become clear once I demonstrate it using a example. So I'll go back to MySQL workbench here. I'll give multiple examples so that group by becomes extremely clear because it's one of the fundamental topics to learn. So I'll basically write a group by query that will allow me to calculate my average salary. I'll rename this as average salary from my employee table. But this time I'll also select my gender columns because I want to calculate this group by based on gender. So I'll select two columns. The first column I'm selecting is gender, and the second column that I'm selecting is the average salary, right? And here I'll do this selection from my employee table. So right now, what will happen is that, so currently this query will not give me any result, so it will throw me an error because this is not a proper aggregation that I'm doing. So now what I'll do is I'll simply call my group by, and I'll mention the column with which I want to do a group by. Right, so here you can see the column that I have selected for grouping is the gender column. And what it will do is that it will take the rows from my employee table, divide it across each category of this gender column. So my gender column has two categories, male and female. So it will create two separate tables for male and one separate table for female. All right. And it will calculate the average for each of these tables separately. So let me print the result here. So now you can see that we have two columns in the output. The first column is the gender column. The second column is the average salary. In the gender column, you have two values, female and male. And here you can see the average salary for each of these two genders. So here the first row contains the average salary for female and the second row contains the average salary for male. So this is where group by comes into picture. Otherwise, if you had to do this, what you would have to do is that you would have to calculate both these numbers separately, all right, which would be a very tedious task. All right, so here this group by allows you to calculate these aggregations with one single line of code. So not only average, you can calculate whatever you would like. So here you have other columns as well. So let me see which other column can we look at. So we have this works on table as well. All right. So what I'll do is let me show you the contents first. So select star from works on. So here you can see in the works on table, you have three columns. The first column contains the employee ID. Second column contains the project number, and the third column contains the number of hours that this employee has worked on this project. So now let's say you want to know what is the total number of hours that each employee has worked across all the projects. All right. So obviously we have multiple projects. So each employee can work simultaneously on multiple projects. So let's say you want to know for each employee total number of hours from works on group by employee SSN. So what this query will do, this query will select two columns, employee ID and the total number of hours from the works on table that I have just shown you on the screen right now. And it will group the results by each employee that we have. So for each employee, it will calculate total number of hours that that employee has worked. So if I execute this query now, so here you can see you have these multiple entries. For first employee, total number of hours are 40. For this employee, total number of hours are 40. For this employee, it is 40. For this employee, it is 35. For this employee, there are no hours, so the values are null. So that's why you are getting null in the output. This is because in the works on table, there is no entry for this employee. So there is only null value present. So aggregation also returned null. For this employee, you have 35 hours. For this employee, you have 40 hours. And the last employee also has worked for 40 hours. So this aggregation allows us to look at how many hours have each employee worked across different projects that they are a part of. All right, this is where group by comes into picture. That is, it allows us to aggregate results, but it doesn't just aggregate results. It aggregates it on the basis of a column that you have specified. So whichever column you will specify, it will aggregate the results by using that column value. So here, the column which we have specified in this query is employee ID, and it is aggregating those results based on the unique value of this employee ID column. Now, in this particular case, you can also use group by with other queries as well. So currently, the group by which we have used it outside any other clause. But if you want, you can also use group by. Let's say you want to look at the average salary of male employees across each department. Right? This query requires a couple of different processes. So let me go back to my SQL workbench and let's try to answer this question as well. I'll write what I was saying here. So we have to calculate average salary of male employees or average salary for male employees for each department. Right? So this is what the query has to be. So calculate average salary for male employees for each department. All right. So in this case, a couple of things must be pretty obvious to you. That is, since we only want to calculate it for male employees, so there has to be a where clause which separates the data or filters the data only for male employees. And this average salary has to be calculated for each department. So therefore, the group by has to be applied for each department that we have. So what I'll do, I'll select department number. Right? I'll also select gender so that you can see what the gender of all the employees is. And I'll calculate my average salary. This will be selected from my employee table. And this time I'll do a group by department number. But this group by is not complete because here, one thing which we have to do is basically we have to first filter the data first. So here, if you do it right now, what will happen is that it will aggregate the data for each department and it will use all the rows, but we don't have to use all the rows. So therefore, what I'll do is I'll only run a filter query here that will filter out the values only for my male employees. Okay, so that is basically what we have to do. So what this query will do, this query will select department number, gender, and average salary from the employee table where the gender of those employee is male, right? So we are only filtering out male employees. And for those rows, we are doing a group by department number. So the output will now contain, here you can see the output contains 3 departments, department 1, department 4, and department 5. Here the gender is male across all the departments, right? And these are the average salaries for each of those genders. So here you can see for department 1 for male employees, average salary is 55,000. For department 4, male employees, average salary is 25,000. Department 5, male employees, average salary is 36,000. So this query allows you to calculate the average salary for male employees for each department. So here you can also use all the other clauses as well. Now let's say you want to sort these results as well, right? So after running this query, let me extend this query further so that the results are now sorted order by, let me use an alias here as average salary. I'll do a order by average salary. Let me do it in descending order. So what it will do, it will sort the results of this query, but in descending order. So if I execute this query now, so here you can see the output results are now sorted in the descending order of average salary. So here the highest average salary is for department number 1 and the lowest average salary is for department number 4. Right? So order by can be used here to sort the results, and plus you can also do a group by to group those results by a particular column of department number. Now it's not necessary that you only have to use one column at a time to do a group by. If your requirement is such that you want to do a group by at multiple column levels. So for example, let me do a simple query here. In this query, let's calculate average salary for each department and salary across each department and gender. Here, basically what I'll do, I'll select 3 columns. I'll select my department number, I'll select my gender, and I'll select my average salary from my employee table. But this time I'll do a group by multiple columns. So I'll do a group by gender as well as my department number. So what it will do, it will calculate for each department and each gender what is the average salary. For department 1 and gender male, what is the average salary? For department 1 and gender female, what is the average salary? For department 4 gender male, what is the average salary? For department 4 gender female, what is the average salary? So if I execute this query now, so here you can see we have the rows for department 1, department 5 gender male, this is the average salary. Department 5 gender female, this is the average salary. For department 1 gender male, this is the average salary. Department 1 gender female, there are no rows in the data, that's why you are not getting that aggregation. But in department 4 gender female, this is the average salary. In department 4 gender male, this is the average salary. So you can use group by for multiple columns as well. So if your aggregation requires you to aggregate data across multiple columns, so you can specify those number of columns as well, and the result will then contain those number of columns in the output. Now there is yet another very important tool in MySQL which is used when you want to filter only the unique values from a particular column. Say for example, you want to take a look at all the manager IDs from your employee table, because in the employee table you also have a column which contains the manager IDs across all the employees, right? So we have multiple employees and each employee has his or her own manager. Right. So now let's say you want to list down all the unique manager IDs from your employee table. So how will you do that? You can use the distinct function or distinct clause to list down all the unique manager IDs from your employee table. The syntax of distinct is pretty simple. That is, after select, you have to write the distinct clause. And after distinct, you write the columns that you want to show only the distinct values from. And then the from statement and the where conditions are pretty much standard, right? So in order to explain this and do a practical on this, let me go back to my SQL workbench. So here we want to print all the unique manager IDs. So there for that I'll select let us select what is the column name? Just give me a second. It's super underscore SSN. Yeah. So the way you print it is that you use the distinct clause and you mention the column name from the employee table. Now in the output here, you will have all the unique supervisor IDs from your employee table. Right? There was one supervisor ID for null as well because one employee did not have a supervisor. That's why here we have a null value available as well, but it's okay. What I want you to focus is on the all the non-null values. So here you can see there are three supervisor IDs. This is the first supervisor ID, second supervisor ID, and this is the third supervisor ID. Right? So you have three managers here, and these are their respective manager IDs. So the main purpose of distinct comes from the fact that it is used to print all the unique rows from your selection. Right? So for example, here if I show you select gender and supervisor ID from the employee table. Execute this query now. So what you will find is that there are few rows which are getting repeated. So if you take a look at this row, this is again getting repeated here. So this row is a repetition, right? So gender male and supervisor ID 33344 something, it is getting repeated again over here, right? Similarly, there will be a couple of rows here as well. So here, one second, let me see. I think that is the only one. But the idea here is to essentially show you that in your selection, if there are any duplicates present. So here you can see there is a duplicate present, wherein this particular row is getting duplicated again down here. So what if you don't want this duplication to happen? So in your selection, if you want to drop all these duplicates, so what you can do, you can just append this with a distinct clause. And this distinct clause will delete any of the duplicates from your data. So here you can see the output will now contain only one occurrence of this combination. So earlier on, this was occurring twice, but now it will only occur once because distinct will make sure that there is no repetition happening across your selections. So it basically only filters or only selects unique rows from your selection. So your whatever queries it is run on top of, it will only show you unique values from that selection. And that is the use for distinct. So distinct allows you to list down all the distinct values from selection. So if you want to filter out or if you want to print total number of managers in your company, so how you can do it? So you can run a count here. So select count, distinct, supervisor ID from your employee table. So what this expression will do? This expression will count total number of distinct supervisor IDs that are there from your employee table. So if I execute this query now, the output will contain 3 because there are 3 managers in my company. And these 3 managers, because earlier on when I had shown the manager IDs, you should remember that there were 3 manager IDs which were non-null. One second, where is that? You can see here there are 3 non-null manager IDs. And if you want to count, you can pass that expression to the count function, and count function will return you the count of those manager IDs. So here you can see the output is 3. So we have 3 managers in my company, and this is the total number of count here. Right? So that is how you can use distinct along with count, and you can use it to count the distinct values in a particular column. Now the next clause is called as having clause. And the use of having is very important, and it's a very common interview question as well. So what's the difference between having and where? In order to understand the difference between having and where, it's very important to understand the sequence of execution of these clauses in MySQL. So right now, what we have shown you is that in a particular, in case of MySQL, the expressions that you write, those expressions are actually executed in a particular order. All right, and the way the order of execution is as follows. So let me go back to MySQL workbench now in order to explain what the order of execution basically looks like. So basically, whenever you write any SQL query, so let's take for example the latest query which we had written, right? So let me close this output here, and let me go back to this query which contains a couple of expressions, which we can use here. Right. So let's use this particular. So let's focus on this particular query. So in this particular query here, you can see we have multiple clauses which we have used. So we have select clause, we have from, we have where, we have group by, we have order by as well. So there are multiple different clauses which are a part of this query. Now, whenever SQL actually goes ahead to execute this query, it breaks it down into logical steps. So there is a logical series of steps which needs to be taken in order to properly execute this query. So the way this query is executed is that firstly, the from clause is executed. So first and foremost, MySQL will execute the from clause. That is, it will first figure out from which table do you want to make this selection. So here first, it will filter out the table from which the selection has to be made. So first it determines whether the table is available or not and all those things. So here first it will go ahead and pick the table from which this operation has to be executed. So this is the first step. So the from clause will execute first. After the from clause is executed, then where clause is executed. Because remember, the purpose of where is to filter the rows on which the aggregations and selections have to occur. So after it has executed the table name or the from clause, it can basically executes the where clause. After executing the where clause, it knows, okay, which rows have to be filtered out from this particular table. So the order of execution is what? The order of execution is that first from, then where. After that, it basically executes the group by, right? So once it has filtered out the rows on which the aggregations has to be performed, it then goes ahead and performs the aggregation. So now it will execute group by. So at the time of aggregating, at the time of doing the group by, here you can see here, once until it does the group by, these columns will not be created. So please keep this in mind that this column of average salary will not be created until this group by operation is done. So by the time this from clause and this where clause were executed, these columns of average salary was not created yet. These columns of average salary will be created once the group by operation is done, because during the group by operation it will use this function to aggregate the salary column, right? So here, until the group by executes, these operations of average computations or aggregations will not be executed. It will execute only when your group by query executes. And when will group by execute? Group by will execute after the where clause. So first from, then where, and then group by will execute. After group by has executed, then you have select execution, right? So once the group by is executed, then it will execute the select statement, because after group by it will select which columns you want to select out of that entire aggregation that you have just performed. So we want to select department number, gender, and the average salary, which is now calculated. And finally, here it will basically last will be the order by. So after select, it will order the results based on whatever condition you have specified. So I'll just write it down at the top here. So the way in the order of execution will be basically first from will execute, right? First from will execute. After that you have where. After where you have group by. After group by you will have select. And finally, after select, you have order by. So this is basically how this query will be executed in a logical sequence. So first your table will be filtered, then the filtration will happen, then group by will happen, and then it will select the columns, and finally it will sort the results based on whatever condition you have specified. Now let me present you with a problem. So I hope this much is clear. Basically how MySQL executes this query in a logical sequence. So this is how the logical sequence of execution goes. Now here, like query is basically this. That is, I want to calculate average salary of departments uh, with average more than, let's say, 30,000. I'm not sure if there are departments with average more than 30,000 or not. This is a random number which I have taken. But the idea here is basically this. That is, what I have to do, I have to filter the results of a group by operation. Right? So let me essentially write down the query first without having any filtration. So basically what I'm trying to do is that I want to calculate the average salaries of all the departments from the employee table and do a group by department number. If I currently print this operation here, you can see we have these three departments right now. So I think the lowest salary is 31,000 and the highest is 55,000. So let me just increase this number to 32,000. Right? So I want to calculate average salaries of the departments whose average salaries are more than 32,000. So just want to show or select or filter average salaries of these departments whose averages are more than 32,000. So right now what we have to actually do here, we have to filter the results based on this aggregation which we have just performed, right? So I want to, so technically what you would think is that, okay, why not just simply write a where clause here? So where, let me just give a name to this particular column as average underscore salary. And I'll do where average underscore salary is more than 32,000, right? Technically speaking, you would think that, okay, this is a correct query because what I want to do is that I want to calculate my average salary and filter the rows where average salary is more than 32,000. But you will be shocked at the time of execution of this query. So that when you try to execute this query, you will basically get an error. You will not get any output, right? So if you try to see the output here, you will see that in the last query here, the output is unknown column average salary in the where clause, right? So here, if you try to read this, I'm not sure if you're able to read this or not, but it says that the error says there's an unknown column of average salary in the where clause, right? So why is this error coming now, right? So for understanding this, you have to go back to the order of sequence of execution, right? So the logical sequence of execution is what? First from will execute. So let me copy this again. I'll copy this again and I'll paste it down here. So the way this will execute is that first from will execute, which will filter out from which table you want to perform the selection, and then where will execute. So just immediately after from, it will try to execute where. Now when it tries to execute where, there is no column called average salary in this employee table yet. So here, if you try to filter the values using the column that you are creating after aggregation, that column will not be available until that aggregation is done. And this aggregation will be done after the where clause will be executed. So therefore, right now, there is no column called average salary in my employee table. Your employee table does not contain a column called average salary till now. So therefore, this particular query will not execute and it will throw you an error. So you might ask me, okay, this is valid. Then what should we do when we want to filter results after a group by operation? So that is where having clause comes into picture. So what you will do here is basically we write having and the condition that you want to apply. So now what will happen is that after group by is executed, MySQL will execute having, and then it will execute the select and order by. So what will happen now? Now it will first filter out the rows in which the average salary is more than 32,000, and it will then select these two columns and then show you the result here. So the difference between where and having is that where is used when you want to filter records from a table which has not been aggregated. But having is used when you want to filter the records from a table which has aggregation. So when you want to filter the records after a group by operation, you have to use having. Otherwise, you can use where. So if you want to filter records from a normal table without having any aggregations and such, you can use where. So please remember, this column here is created after the aggregation is performed, right? So if your filtering requires you to filter records based on an aggregated column, you have to use having. If your filter operation is if your filter operation is based on a column which does not require aggregation, then you can use normal where clause as well. Because remember here previously, in this particular query, we did use a where here, but this particular where statement was based on the gender column or the sex column, which was already present in this employee table. That's why it executed correctly. But right now in this query, this average salary will be created after the group by operation will be done, and therefore it is not there until this group by operation is done. And hence, once this group by is done, you will have your having, and then having will filter the records having the salary more than 32,000, and finally you will have your results as per your requirement. I hope the difference between these two is clear to everyone. What is very important to understand, I'm again repeating, it's one of the favorite interview questions from MySQL perspective. Next, we have date functions available. So date functions allow you to work with dates in MySQL. Now, dates are very important because a lot of times these have useful information which you can later use to, create new columns out of. So, for example, usually what happens is that in a date you have day, month, and year written. So here in this case, what you can do, you can extract these months, extract years from these dates, and then calculate aggregations based on these extracted values. So the function which is used to perform these extractions is the extract function. The function which is used to extract these entities from dates is called extract function. And the syntax for using extract function is basically this. That is, first you call the extract function. Then you have to write the unit that you have to extract. This unit could be day, month, year, hour, minute, second. Depends whether you have date or date time values. Right. So if you just have a date, then you can extract hour, day, month, and year. If you have date and time both, then you can extract day, month, year, hour, minute, second. All these entities can be extracted from a date time value. So I'll explain this with an example as well so that it becomes a bit more clear. So let me go back to MySQL workbench here. All right. So in my employees table, select star from employees table. If I show you the current rows that I have, so here there is a column called birth date. So I can use this column of birth date to extract, let's say, year of birth of all the employees. So what I'll do now is that let me do select extract. Uh, Let me extract year, right, and uh, year from birth date as year of birth from employee table. So here you can see we are able to extract what is the year of birth from the employee table. So this extract function, the syntax is basically this only. That is, in the extract function, you write which entity you want to extract. So right now we are extracting year. From which column you want to extract this? I want to extract this from my birth date of birth column, right? So birth date column. So this will extract year from my birth date column. It will rename it as year of birth, and this is the table name from which this extraction will happen. So it will it will extract year of birth from this table, and it will rename it as this particular column. So here you can see the column name, and this is the year of birth from my employee table. All right. So if you want, you can even actually you can count the number of employees which are born in each year. All right. So what you can do is that you can do select count star and year of birth from this employee table and do a group by year of birth. Okay. So what this will do? So basically, this will calculate total number of employees that are born in each year. Right now, there is one employee that is born in each year, but the idea of this query is to basically show you how you can create or how you can use these extractions and perform such analysis as well. So in this, we are able to see how many employees are born in each year. Similarly, you can also extract month as well. So just like year, you can also extract, if you want, you can also extract month. So the syntax is again the same. So extract month from birth date as month of birth. Table will remain the same. So this will basically calculate the birth month as well. So here you can see so currently these are all dummy dates. So all the month numbers are one only. So therefore there is no difference right now. But the idea here is basically to just to tell you about how you can extract these different entities from a date. So just like month, you can also extract day. So day, month, and year are very commonly extracted entities from a date column. And this is how you can perform that extraction and use extract function to extract these entities from a date column. And the last topic for the day is to understand the case when statements in MySQL. So the case when statements are used whenever you want to create a column which contains multiple conditions. Let's say in this particular case, you want to create a column such that depending upon the salary, you want to filter the employees who are earning more than the average salary, equal to average salary, and lesser than the average salary, right? So you want to create a column. That column will basically tell you if an employee is earning more than the average salary, equal to the average salary, or less than the average salary. So how will you do it? That is where the case when statements comes into picture. So it's basically a control flow function. So it allows you to control the flow of the code depending upon the value at a particular row has. Right? So here what we do is that we write a condition That condition will basically check if a value satisfies that condition, do this. Else check for other condition. If that value satisfies that other condition, do something else. Else check for the third condition. If it satisfies the third conditions, do something else. Otherwise, go ahead with the default value. So the flow basically depends upon what your value is and which condition it satisfies. All right. So here I'll explain it with a simple example. Again, I'll go back to Workbench, and so that the example becomes a little bit more clear. So I'll come back here. So I'll select my employee ID, right? So what was the column name? ESSN was the column name, I think. And let's write a case when statement. Case case when case when salary is less than what should be the average salary, right? So let me calculate the average salary here itself. Case when the salary is less than average salary, then let me return what should we write? Let's write just less here. When salary is equal to average salary, then equal, right? So here we have written 2, and finally else more and end. And let me rename it as pay scale, and this is basically done from my employee table. So here this is a very simple case when statement. So I'll explain the logic behind this case when statement and what we are doing here. So if you read this case when statement, what we are trying to do, we are selecting two columns. The first column which we are selecting is the employee ID, and the second column which we are selecting is the pay scale. Now this pay scale column is created by using this case when statement. In this case when statement, the value which is assigned to each row depends upon the current salary of this employee. So if for a particular row, the salary of that employee is lesser than the average salary from my table, then the output shall be less. When the salary is equal to the average salary, the output shall be equal, else the output shall be more. Right? So if an employee earns lesser than the average, for that row the output will be less. If he or she earns equal to the average, the output will be equal. And if both the conditions are not getting satisfied, then the output shall be more. Right? So there can only be one of the three cases. Either the employee is earning less than average, equal to average, or more than average. Right? So therefore here the output is only containing one of these three values. And for each row, whichever condition it will satisfy, if it will satisfy the first condition, for that row the output will be less. If it is satisfying the second condition, the output will be equal. If it is not satisfying both the condition, else will return the default value. So if both the conditions are not getting met, the default value will be more. That is, if the employee is earning more than the average here, and that column will be renamed as pay scale column. So if I execute this now, 1 second. I think I have to write it is actually aggregating the result here. So let me just print the average salary here. I think there is one small mistake which has happened. Let me correct that. Select average. I have not shown you nested queries. That's why I'm writing it like this. Otherwise, we have to do it using nested queries. Sorry for that. So select average salary from my employee table. So later in the next class, we'll talk about nested queries as well. So then I'll give you yet another way of doing this. But for now, I'll hard code this value as 35125. So if this is less than 35125, which is the average salary, by the way, we have calculated ourselves. If it is equal to 35125, then I want to print equal, else I want to print more. If I execute this now, right, so it will show you for each employee what is the output. So in this case, for the first row, the average salary for this employee, so salary for this employee is less than average, so I'll also print the salary as well, right, so that it becomes a little bit more clear. So here you can see for the first employee, the average salary for this employee was 30,000, and 30,000 is less than 35,125, so therefore the output is less. For the second employee, the salary is 40,000, which is more than, so therefore the output will be more because both these conditions will not satisfy. For third employee, again the salary is less than average, so therefore the output is less. For this one, it's more. For these next two, it's again higher, so therefore the output is more. And for the next two, they are less. So here, using this case when statement, we are able to create a new column in which the values depend upon a condition. And a row, if it satisfies that condition, it will have a value. Otherwise, it will move on to the next value in that condition. If it is not satisfying that condition, it will move on to the next value. If it is not satisfying even that condition, then finally there will be an else statement which will return you the default value. So here you can see case when. The syntax is pretty easy. You start with the case keyword, then after when you write the condition, and then after then you write the value which has to be returned if this condition is true. Then if this is not satisfied, then you again can write another when clause and write the condition which has to satisfy. If it is again not matching, then if it is matching, then whatever is to be returned, you write that. Else, whatever you have to return by default, you will write that. And the last keyword is end. So after all the conditions are written, you have to end the case when statement with the end keyword, and then you can rename it as whatever column you want. So here I'm renaming it as pay scale, and that will column name will come up in the output. All right. So this is how you can use case when statements to create a new column from an existing column depending